Hello everyone. A very interesting topic. I'm going to teach you increasing and decreasing function. This is the part of application of derivative that by using the derivatives or differentiation, how can we say that the function is increasing or the function is decreasing? So first of all, we have to understand what do you mean by increasing or decreasing function. So let us take an example of a function, and I have drawn a curve of this function. Suppose on x-axis I am taking two values x1, and the value of the function at x1 is denoted by this is fx1. Similarly, the value x2 and the value of the function at x2, that is fx2. So I have taken two values, that is two inputs and corresponding outputs. See, x1 is before x2, it means x1 is less than x2. What about their outputs? Obviously fx1 is below, then this is fx2. fx1 is below than fx2, so you can say fx1 is less than fx2. Finally, I am concluding it that x1 is the smaller value, so its output is also smaller. If x2 is the larger value, then its output is also larger. It means as we move in x-axis, as the value of x is increasing, corresponding outputs are also increasing. So small input, small output, bigger input, bigger output. It means the value of the function is going proportionally with the value of x. Such functions are called increasing function, and it is obvious that the trend of the curve, you see, the function is increasing. Now what about the decreasing? So this function is, I can write increasing. This function is increasing. Now come to the second curve. In this is x1 and the corresponding output fx1. This is x2 and the corresponding output fx2. In this graph, x1 is less than x2, but fx1 is greater than fx2. So smaller value have bigger output. Smaller value is having bigger output, and the bigger value is having smaller output. It means as we increasing on x, so the value of x is increasing, but the value of the function is decreasing. It means the value of the function is decreasing with the increasing of x. Such functions are called decreasing function. Such functions are called decreasing function. Now, what do you mean by strictly increasing or only increasing? See this function. In this curve, here to here, the function is continuously increasing. But after this, the function become constant. It's not increasing. Because in this domain, only x is increasing, the height of the function is not increasing. So, function is stopped increasing for a moment. But afterward, that function start increasing. So I cannot say this function decreasing. It is not decreasing. It is increasing, constant and increasing. So I can use the word strictly increasing to this curve, because this function is continuously increasing in all domain. It is never stopping. So I can use the word strictly with this function, that is strictly increasing, and this function is only increasing. This function is only increasing. So this is strictly increasing and this is increasing. Similarly, come to this function. This function is decreasing, and for a while it's become constant, then decreasing, then constant. So the trend of the curve, you see, it is decreasing and sometimes it is constant. But see this curve, it is continuously decreasing. It is continuously decreasing. So I can use word strictly. So it is strictly decreasing, and I can write here But in some cases, whenever I am saying that a function is increasing, so or sometimes strictly increasing is not written. So that means I can include this or this portion in increasing only. So these are the introduction of increasing and decreasing function. Now how we can use differentiation in increasing decreasing. So just see, I have drawn this graph and you know the function is increasing as I have shown in previous discussion. Now if I am drawing a tangent to the curve at this point, this is your tangent. I have taken an arbitrary point on an increasing function. You see the trend that the tangent will always make an acute angle with the curve. It means if you are drawing anywhere, if you are drawing tangent anywhere to increasing function, you will have an acute angle. It means the slope of the tangent will be positive. And you know the slope of the tangent is dy upon dx. It means for increasing function, dy upon dx is greater than 0. Or you can say the derivative f dash x is greater than 0. For increasing function, the differentiation coefficient, that is f dash x, will be greater than 0 for throughout the domain. But for decreasing function, dy upon dx, you see if I am drawing a tangent, so it is making an obtuse angle, and you know whenever a tangent is making an obtuse angle, then the slope is negative. It means we will have dy upon dx less than 0. Or you can say the derivative, sometimes we can write dy upon dx and sometimes we can write f dash x is negative. So this is the use of differentiation in increasing and decreasing function. For increasing function, the derivative, that is dy upon dx, will be positive. And for decreasing function, the dy upon dx or the derivative will be negative. And how can we conclude strictly increasing or increasing? You know, if it is strictly greater than 0, then it is strictly increasing. And if it is increasing, then in this case, we can write dy upon dx greater than or equal to 0. So I have included 0 also, because on some portion tangent is become parallel to x-axis, that is dy upon dx equal to 0. But in such curve, dy upon dx will never be 0. It means dy upon dx will be strictly greater than 0, then it is strictly increasing. And if dy upon dx is non-negative, that is 0 greater than 0 or equal to 0, then this function is only increasing. Similarly, dy upon dx is strictly less than 0, then this function is strictly decreasing. This function is strictly increasing. And only decreasing function dy upon dx less than 0 or equal to 0. So now see one more topic. Suppose I am taking a function fx is equal to e to the power x. You know the graph of this function is like this. So this is a always increasing function. It means this function is always increasing in its domain. So by the use of calculus, you know, if I am doing f dash x, so I have e to the power x. Because the differentiation of e to the power x is e to the power x. You know, e to the power x is always greater than 0 for every value of x. Whatever value of x you are taking, e to the power x will always be positive. That is, the derivative of a function is positive. This means this function is ever increasing, is strictly increasing. So this function is not changing its nature, it is increasing, it's showing a particular trend. So if a function is showing a particular trend of whether strictly increasing or whether strictly decreasing, then such functions are called monotonic function. Such functions are called monotonic function. So this is called monotonic function. It means these functions are monotonous. They either will increase or either they will decrease. But you know about the sine function. I am drawing the graph of the sine function. You see If I am drawing, this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and this is 5 pi by 2. So starting from 0 to pi by 2, you see the function is increasing. Then after pi by 2, the function is up to 3 pi by 2, it is decreasing. Then again it is increasing. So in whole domain, it is increasing as well as decreasing. So this function is not monotonic. So monotonic means either increasing or decreasing. So sine function is not increasing throughout its domain. To understand the concept, you have to see some question. Stay connected. See this question. Show that y is equal to log 1 plus x minus 2x upon 1 plus x, and x is given greater than minus 1, is an increasing function of x throughout its domain. So what do you mean by the domain of the function? Because see the restriction on x is greater than minus 1. You cannot take the value of x is minus 1 or less than minus 1. So this is the domain. So that your domain is minus 1 to infinity. This is the domain of the function because it is given here. So this means this interval is our domain where from we can take the value of x. Now see your function. You know, to check whether the function is increasing or decreasing, what to do? You have to find dy upon dx first. It means you have to find derivative. So this is your y. So you have to find dy upon dx, which will be differentiation of log 1 plus x. So 1 upon 1 plus x, and differentiation of this. So 1 plus x as it is, differentiation of 2x is 2, then minus 2x as it is, and differentiation of 1 plus x is 1. I am using quotient formula here, and 1 plus x whole square. So I am saving your time. After solving this question, you will have, I am writing down, it will be x square 1 plus x and 2 plus x whole square. So you will get this value. Now if I have to show the function is increasing, I have to show that this derivative is greater than 0. How can I prove it? See, because x is greater than minus 1. So see the number line. This is minus 1, 0, 1, 2. So after minus 1, there is a number 0. So you know, if x is greater than 1, so x square be positive or maybe 0. So the numerator can be positive or 0. Now think about the denominator. Because x is greater than minus 1, so 1 plus x is always greater than 0. It is always positive. Similarly, this portion 2 plus x square is always positive. It means there is no negative value. For whole function you see in numerator, in denominator, there is no negative value. It means your dy upon dx can never be negative. Yeah, it may be 0 on a particular situation when x is equal to 0, but never negative. So it will be 0 or greater than 0. So I can write like this. So I cannot say that this function is strictly increasing. So I will write, because dy upon dx is greater than equal to 0. So given function is increasing. So more question on increasing and decreasing function. You have to watch the next sequel of this topic, I mean increasing decreasing function part 2. So keep watching my videos. Thank you very much.